In this video clip, we are going to look at hypothesis testing, and we're going to test a claim about a mean when the standard deviation of the population is known. We're going to take a problem out of the textbook. Let me find it. Whoops, wrong one. Okay, page 426 in your textbook, example number 1. Now, what we want to do is we want to take this problem and we want to pick out the parts that we're going to use. Notice it says people have died in boat accidents because an obsolete estimate of the mean weight of men was used. Using the weights of the simple random sample of men from data set 1 in Appendix B, we obtained these sample statistics. So what happened is there was a problem with people dying in boating accidents, so they're going to make a claim in a few minutes, and they had to collect a sample to use to determine if this claim is accurate or not. And you can actually take the values at the back of the textbook and you can plug those into your calculator and you can find the sample statistics that they're listing here. But we're just going to use the statistics for our example today, so instead of using the data points. But notice there was a total of 40 points that we're going to use, that they used, and the sample of those 40, the weight of the men of the 40 in the sample was 172.55 pounds. Now, research from several other sources suggests that the population of weights of men has a standard deviation given by sigma equals 26 pounds. Notice it says the population of weights of men has a standard deviation. Also, it gives us sigma. This tells us that we're dealing with a population standard deviation. That should remind us that we want to try to use Z in this problem. It does not tell us it's normally distributed, but it does tell us that n is greater than 30, so we can continue with the problem. Notice it says use these results to test the claim. Now, this is very important. Always look to see if you can locate the claim first, and then we will use the claim to set up the null and the alternative hypothesis, and we're going to test that claim to see if it's accurate using our sample. So notice the claim that men have a mean weight greater than 166.3. Our claim does not have an equal. That's important at the very end because we're going to use a flowchart in your formula table that will ask you, does the claim have an equal sign? So no, our claim says that men have a mean weight greater than 166.3. Now we're going to use that in a few minutes and change it to symbols and then write our null and alternative. Another part in this problem that's very important is our level of significance. Notice alpha is 0.05. We will be using this to test our p-value to see if it is greater than or less than this number. So we're going to be using what we call the p-value method in this. So I took all the information from this problem and I summarized it. So we have, let's see, let me find it. The claim, men have a mean weight greater than 166.3 pounds. We want to take that and write it in symbols. So what we have is the mean is greater than 166.3. That is our claim. This would be considered our alternative statement because remember, a null must have an equal sign. This one does not. So this goes in the place of our alternative hypothesis. I hope I said that right at first. But this is our alternative. Notice the null has to have an equal sign. So if we take this and change it to an equal, we now have the null. What happens is when you test a hypothesis statement, we're going to test to see if we reject the null or we fail to reject the null. Now notice, if we reject the null, that means we're actually accepting the claim because these go together. So that's what we're trying to find out. Do we accept it or do we reject the null? Okay, so that's where we're leading up to. Notice I went ahead and wrote out the other information. The number in the sample was 40. The mean in the sample was 172.55. The standard deviation of the population, that tells us to use Z, was 26, and then our level of significance is 0.05. We're going to call up our calculator, turn it on, and I'm going to clear. What we're going to do is go to Stat and move over to Test. And since we were dealing with a Z because we have a standard deviation of population, we're going to pick number 1. Now, if we had a sample standard deviation and N was greater than 30 or it was normally distributed, we would use the t-test. Okay, so right now we're using a z-test. So we're going to use that. Now, the data is in the back of the textbook. If you wanted to go actually type in the points, you could type that in list 1 and select data. But we're just going to use the statistics that we were given. So we're going to highlight that by pushing enter. We're going to move down and notice we have to type in the mean of the population. That comes from our null hypothesis. So this mean represents, it comes from the null. So we have 166.33, so you'll type that in. Notice the standard deviation of the population is 26, so you'll have to come down and type that in. And then this is the sample mean, which comes from the problem. They told us 172.55 was the sample mean of those 40 men. Okay, the number in the sample is 40. Now the next part is wanting you to tell your alternative statement. Which direction? Is it a two-tail, not equal to? Is it a one-tail which is less than, or a one-tail that's greater than? Notice, anytime that you deal with a not equal, we will have a two-tail test, or two tails that we will be looking at for our p-value. Notice in our particular problem it says greater than, so we need to move over on top of greater than and push enter, and that highlights that. Now, what I'm going to do for a second, I'm going to draw this just to show you what this graph looks like. Think about it's greater than the z-score. Now, what happens is you can actually, if you need to go calculate the z-score using the formula, if your instructor asks you to do that, you can go at this point and go look up your test statistic, calculate the z. What I'm getting ready to do, I'm going to show you the z. It's already been calculated by the calculator, so I'm going to go down to draw and push enter. And what happens is, notice this is a one-tail graph because it says that the mean is greater than 166.3. Okay, the z-score for that is located right here at the beginning of the shaded area, and it tells us the z-score for this, which is your test statistic, is 1.52. Okay, now before when we wanted to find the area under the curve, we would use normal CDF. We would type in 1.52 comma, and this goes off to positive infinity, so we'd put in 99999, close it up, push enter, and it would give us the area under the curve. Well, this has calculated the p-value for us, the area under the curve. Now, let me go back and call up the statistics again for this. Let's go to z-test, and I'm going to have it calculate this for you. Okay, so now what happens is this is saying, okay, we are looking at a z-test when the mean is greater than 166.3. That's our alternative. So always check and make sure that matches. Notice the z-score is 1.52. That's your test statistic. Notice your p-value is 0.0642. Now, this p-value is going to be very important because this is how we're going to test our claim. So let's look at the next page of this. Okay, what we want to do is compare your p-value to the significance level. Remember, significance level is that alpha, which was 0.05 in our problem. If your p-value is less than the significance level, you reject the null. Now, if you remember back in the probability problems we worked with, if your probability was less than 0.05, we said that was an unusual statement. Well, that's where this is coming from. We're looking to see if our p-value is less than our significance level. Your significance level is not always 0.05. They may use a 90%, then your significance level would be 0.10. They may use, I was trying to think of another one, 99%, so your significance level would be 0.01. Okay, a lot of times they'll use 0.05. So in this particular problem, it says 0.05. If your p-value is less, you reject the null. If your p-value is greater, you fail to reject the null. Now, our p-value was 0.0642. Now, the bullets that they used in the PowerPoint turn out to be lines, so do not think this is a negative sign. It's not. Okay, so your p-value is positive. We know all proportions or probabilities are positive, okay, because they're between 0 and 1. So this is 0.0642. That is greater than our alpha, our level of significance, which is 0.05. Well, if it's greater, then you fail to reject the null. Okay, now think about this. If you fail to reject it, we're going to accept it, okay, for right now. The claim before was men have a mean weight greater than 166.3. And we have failed to reject the null. In just a few minutes, we're going to use the formula sheet to draw a conclusion, but let me pull this up and show you something. Okay, we failed to reject the null. That means we're going to accept this, okay? Well, if we accept this, that means we're claiming that this is not accurate, okay? Because we failed to reject that. And remember, this went with our claim. That doesn't always happen. Sometimes your claim may be your null. You just have to pay attention to what it says. So we need to go down to our table that's in your formula sheet, and we're going to go through a series in your flow chart that says, does the original claim have a condition of equality? No. Your original claim said that the mean was greater, so no, it did not have an equal sign. Did you reject the null? No. We failed to reject. So we come, it says, well, first of all, we did not have an equal, so we're down here. Do you reject? No, we failed to reject. So we used this statement to make the claim, or to make our conclusion, okay? So notice there is not sufficient evidence, sample evidence to support the claim. So if we go back to this, we can see that our final conclusion, there's not sufficient sample evidence to support the claim that the men have a mean weight greater than 166.3 pounds. And I also want you to see this at the bottom. It helps you to decide if you should use a T or a Z, which is a normal distribution. Z means normal distribution. So notice a T distribution, the standard deviation is not known, and either a normal distribution, it's either normally distributed, or it's the standard deviation is unknown and n is greater than 30. Notice if we were going to use a Z, the standard deviation of the population would be known, standard deviation, and it'd be normally distributed, or the standard deviation is known, n is greater than 30. So that's a summary of that, if that helps you. But we have a final conclusion here drawn from, and we have to follow the steps. So this should help you when you're working with problems, when you're testing a claim about a mean, the standard deviation is unknown.